Ek lees net wat ek sien. Okay, and there they have a little table where they say 1 picocoulomb is equal to 1 times 10 to the power of negative 12 coulomb. En dan het hulle hom vir jou uitgeskryf ook. Ek gaan nie nou dit doen nie. Okay, so 1 nanocoulomb is gelyk aan 1 maal 10 tot die mag min 9 coulomb. 1 microcoulomb. Micro is daai snaakse, dit lyk soos 'n klein letter I, maar het 'n ekstra stertjie by. Is 1 maal 10 tot die mag min 6 coulomb. And 1 millicoulomb is 1 times 10 to the power of negative 3 coulomb. Okay. These are very important when you are calculating N, which is the amount of electrons transferred. Dan moet jy hierdie ken. Okay. So now to the homework that I gave you guys, which obviously all of you did because you watched the video and you respect one another's time. Wat het ek neergeskryf? Okay, oefening 10 op bladsy 131 en die eerste een wat ek vir julle gegee het is nommer 9. Hy is eintlik op bladsy 132. So they say, in the following table, gee hulle vir jou data van 'n voorwerp wat deur wrywing negatief gelaai is. Voltooi die tabel deur te bereken hoeveel elektrone in elke geval oorgedra is. Now, you don't have space to write down the formula each time, but remember when you are doing these in an exam or in a test, you have to write down the formula. So you'll see on page 132 you have the table, and on the right hand side of the table you have a little gap. So there, write down the formula for yourself. The formula that we are using is given on page 129, and it's given as Q is equal to NQE. In daai ene is Q die lading. In other words, the charge on the object, and that is measured in coulomb. Not nanocoulomb, not microcoulomb, not picocoulomb, coulomb. This is the amount of electrons, and this is the charge of an electron, which is equal to negative 1,6 times 10 to the power of negative 19 coulomb. Klein bietjie lading. Een elektron het 'n verskriklike klein lading. Okay, now when we are doing these calculations, stel jy nie jou plusse en jou minusse in nie. So when you are busy with these specific calculations, when you are using this formula, you do not substitute the plus and the minus. You just use the absolute values. Okay, so al is hierdie lading minus 1,6 maal 10 tot die mag min wat ook al, ons gaan hom nie instel nie. Die rede daarvoor is, as hierdie lading positief is, positiewe lading is, en daar's negatiewe ladings by die elektrone, dan gaan dit ons heeltemal de mekaar maak, Maar wat is 'n positiewe lading? Hoe kry iets 'n positiewe lading? Hy verloor elektrone. Stem julle saam? It loses electrons. So this one is just to calculate how many electrons did an object lose or gain. We don't care whether it gained it or it lost it. We are just calculating how many electrons were transferred. En dit is hoekom wanneer jy hierdie formule gebruik, gaan jy nie enige tekens instel nie. Are we clear on that? Okay, but they're not going to start you off with this. They're going to start you off with two spheres, come into contact with one another, and then they're separated. Do we know how to calculate the charge on the two separate spheres then? Yeah, no? Then they're going to ask you, what is the change in charge for each of the two spheres? Do we know how to do that? You would if you watched the video, okay? And then they are going to ask you how many electrons were transferred. Okay. Maar eers, nommer 9.1 vra reguit vir jou die aantal elektrone. So, if the charge for number 1 is negative 1,6 times 10 to the power of negative 19, and they're asking you for the amount of electrons, then obviously you guys don't have space to substitute it, but you just say N is equal to the charge divided by QE, So the charge in this case, and we don't do it with the minus, divided by that will give you 1. So if something has a charge of negative 1,6 times 10 to the power of negative 11, your answer is 1 electron. Sy aantal elektrone is 1. Yes. Onthou dit gaan in hierdie geval het hy 'n negatiewe lading, né? Nee? This one has a negative charge. So did it gain or lose this 1 electron? Het hy hom bygekry of het hy hom verloor? Hy het hom bygekry. So ons kort hierdie plusse en die minusse om te sê hoeveel elektrone het hy bygekry of verloor het, né? Nee? So ons stel dit glad nie in nie, anders raak dit verwarrend want dan gaan jy dalk hier ergens kry n is gelyk aan minus 5 elektrone. Né? Nee? En in daai geval gaan dit dan 'n bietjie verwarrend raak. So we only use this to indicate did it gain the electrons or did it lose the electrons. Stem julle saam, 'n voorwerp wat negatief 1,6 maal 10 tot die mag min 19 lading het 1 elektron gekry deur wrywing, né? Nee? Maar ons stel hierdie tekens in wanneer ons daai 1 elektron uitwerk. Now for the second one, let's carry on. Negative 3,2 times 10 to the power of minus 19. If you substitute it in there, do you agree that you got 2 electrons? Nee? Hoe kry ek dit? Ek gaan sê daai minus 3,2 maal 10 tot die mag min 19 op 1,6 maal 10 tot die mag min 19. Ek het nou verkeerd gepraat. Jy doen dit albei sonder die teken. Okay, then number 3, we have negative 3,5 times 10 to the power of negative 19. And you get 2,19 electrons.
So with all of those, don't use the minus.
No, no way. Never when you're using that formula. Okay, ek gaan nou net 'n bietjie vinniger begin invul want dit is nou oor en oor dieselfde ding. By nommer 4 kry jy 3 elektrone. By nommer 5 kry jy 3,5 elektrone. I'm just substituting the charges into this one over and over and over again. And for number 6, can I help you guys? Are you fine? You get 100 electrons. Okay. As jy nou toe jy jou huiswerk gedoen het, minusse en goed gebruik het, moenie worry nie. Onthou nou net van nou af. Wanneer ons besig is met spesifiek daai formule, no negative charges. I will upload the video as well. Okay. Nou by 9.2 sê hulle vir jou, watter gevalle sou nie moontlik gewees het nie en gee 'n rede vir jou antwoord. If you look at those 6 different cases, which ones of those will not be possible and why? Dink aan hierdie as 'n fisiese konsep. Iets kry elektrone of iets verloor elektrone. Dis hoe iets 'n lading kry, né? If it gains electrons, it becomes negatively charged. If it loses electrons, it becomes positively charged. So there is a transfer of electrons to form a charge, né? Stem ons almal daarmee saam. So can you transfer a 0,19 electron? No. Jy kan net 'n heel getal elektrone oordra. Do you agree? The number of electrons, an electron is infinitely small. It is unimaginable how small it is. So you can't go slicing that up into fractions further. An object gains electrons, not fractions of electrons, or loses fractions of electrons. No, not whole electrons. Okay, so do you agree that for this one, case, nope. Case 3 and 5 is not possible. And your reasoning will be, you cannot transfer fractions of electrons. Jy kan nie dele van 'n elektron oordra nie. And then for 9.3, I want you to write in brackets there next to it. It's on page 129. You will see there's a block on page 129 that says die beginsel van kwantifisering van lading en binne in daai blokkie staan daar elke lading is 'n heelgetal in die heelal, bestaan uit heelgetal veelvoude van die lading van 'n elektron. Okay. Why? Because a fraction of an electron can't be transferred. So whether something has a positive charge or a negative charge, in the case of a positive charge, it has lost a whole number of electrons, and in the case of a negative charge, it has gained a whole number of electrons. Jy kan nie 'n gedeelte van 'n elektron bykry of verloor nie. En dan het ek ook vir julle nommer 16 gegee, né? Just those two. Kyk, kom ek stop net die video.